Hello students, welcome to the next lecture series of Basic Electrical Engineering. Today we are going to see what is the EMF equation of DC generator. EMF equation of DC generator. So what is the EMF equation of DC generator? We are going to see here. So the terminology what we are going to use for EMF equation of DC generator, first we will see that. So phi is the flux per pole, phi is the flux per pole which is measured in Webers. Next is A is the number of parallel paths, A is the number of parallel paths. So that depends upon the winding. A is equals to P for the lap winding, A is equals to 2 for the wave winding, and Z is the total number of conductors, Z is the total number of conductors. And next A is A we have taken, N is equals to speed in RPM, speed in RPM. What is the RPM? Means revolutions per minute, revolutions per minute. EMF generated, EG is equals to, we can write it as EMF of generator, EMF of generator. So that is equals to EMF per parallel path. First we will consider, then we will multiply the number of parallel paths. So here flux phi is equals to, we can write as Ni by reluctance. What is Ni? Ni is MMF by reluctance. Okay, so let us see how the EMF we can calculate. So let us consider this is the armature having the number of poles are like this. So let us consider the 4 poles are generator. In this middle it is the conductor, that is armature is placed here, having the conductors will be like this, it is rotating. So this is the north pole and this is also a north pole, south pole and south pole. So always the flux lines will travels from where to where? Here, from north pole to south pole like this. So always it will travels from north pole to south pole, and this north pole will have the field windings will be like this. That means every pole it will have the field winding like this. So this is the, so conductors are rotating in the gap between the poles and the armature. Okay, so in one revolution, flux cut by the conductors, flux cut by conductors. So how much of flux cut by the conductors in one revolution is, that is P into phi Webers, P into phi Webers. The speed is given as, what is the speed? That is speed is equals to N RPM, N RPM. Time taken for one revolution, time taken for one revolution, time taken for one revolution. Here you see this equation. So for n revolution, how much of time taken it is? For n revolution, it is time taking, it is 1 minute. 1 minute means we can convert it as, that is equals to 60 seconds. So for one revolution, how much time it will take? That is 1 by n into 60. That means 60 by n revolutions per second here. So here we can multiply. So what is the EMF? Now we will write EMF per parallel path, EMF per parallel path. That is what our target. Before going to that, we will write EMF for each conductor, EMF for each conductor. Okay, so that is d phi by dt, d phi by dt. D phi means what is the flux cut? That is phi pi, and change in the time is 60 by n. So we can write as P phi n divided by 60. Next you see here, EMF for each parallel path, that is our target. So EMF per each parallel path, EMF for each parallel path is equals to P phi n divided by 60 into, so there are z number of conductors, just I am dividing with the number of parallel paths, so that you are going to get EMF per each parallel path. This can be modified as phi n z by 60 into P by A. Why we are modifying this? First see here. So this is the EMF equation of DC generator, very important equation, very useful for the problem solving. So very important equation for the external exams, you are going to get the problems also based on this. So this EMF generated is equals to the back EMF in case of motor. In case of motor, it is equals to back EMF. Here only I am explaining. The back EMF also we can write as phi n z by 60 into P by A, because the construction wise there is no difference between the motor and generator. Why we are writing this P by A as separate? If you consider for the lap winding, if you consider, so lap winding, it is EMF generated will be is equals to phi n z by 60 into P by A, that is P by P only you are going to get, because A is equals to P, PP will get cancelled, that is phi n z by 60, that is the EMF generated in lap winding. In the case of the wave winding, here, so EMF generated is equals to phi n z by 60 into, so P by 2 we can write, that is phi n z P by 120 we can write. This is in the case of the wave winding, that's why we are written separately. So if once the machine is designed, so Z, P and A are constant, we are not going to change once the machine is designed. So in this case EMF generated, if you Z, P and A are constant, only remaining two are variables are phi and n. So EMF generated we can write as proportional to phi, and it is also proportional to n. If you draw the graph, of EMF generated and with respect to the flux, the graph will be looking like this. So this is given for n1 speed. If you are increases the speed, so what will happen? The graph will be shifted upwards, that is n1 is greater than n2. If you decreases the speed, what will happen? So the speed will be like this. So n3, which is n3 is less than n1. So for given speed you can observe the what is the speed will be changing. So for given flux, so you can observe the speed will be, so if flux is constant, whenever you are increasing the speed, so the EMF also will be changes here, that you can observe in this graph. So that's all in this video. In the next video we will see what is the different types of DC generators are there. So if you are seeing the first time this channel, please like, share and subscribe the channel. Thank you very much.